Okay, so for part 2, I'm just going to show you how we can also kind of use the graph on the calc, the TI Inspire to kind of help us out here. So if I go to my graph, first of all I have to graph this as a parametric. To do that, I'm going to go to Menu, and when I go Graph Entry, I go down to number 3 for a parametric. And it's going to set me up a parametric equation. Now again, this is from the last question, so I'm going to graph my derivative here. And if you notice, I'm looking for the acceleration like we did before. And on the part D, on the last part, we're going to look for the position at part 1. So looking at a derivative and an antiderivative here. So if I type in my derivative graph, okay, I'm just going to type this in as this. The sine of t cubed, t caret 3. Now you have to use t's here. Y of t, same thing. It's my even though it says y of t, I'm really using my derivative right there. So it says cosine of t squared. T squared. And I just press enter. And you get a big ugly box. It's not really a box here. So let me scroll out of here real quick. It's not really a box. Let me move this out of the way. What it really is, if we go back to our graph, go to tab, go back up here, change your t values. See, the problem is we're going around, like you imagine like your t is like being a time. We're going between 0 and a little over 6 seconds here. Now the t step tells me it's like a blink. It's like a frame. It means every 0.13 seconds we take a picture. So there's a lot of pictures between 0 and 6.28 if every 0.13 seconds or parts of a second we're taking a picture. So we can kind of limit the number of points here by changing our t value. Let it go to 3 instead. And again, you want to only go to 2 pi, but I want to see what this graph kind of looks like here. If I press enter, you kind of see what's going on. It's kind of wiggling back and forth as time goes on. So that's what our graph actually looks like right here. Now, the graph is not necessarily the important part. What I'm going to do is I'm going to use the graph, my equation in the graph, to help me solve the problem here. So let me go to my home screen. Let me clear this out. I don't know. So let's say I want to find the derivative now. What we can do is if I go to the derivative on my graph, my home screen, sorry, let me get back out of there, say that again. I want to find the derivatives here of my function. Now I got the actual derivative, and in part 1 we just plugged in the 2 for each one of those. But we can do this on the home screen as well. If I go to Menu, go to Calculus, I want to find a numerical derivative at a point. So I've just pressed that button there. Now I'm in parametrics, and I can keep in terms of x, but that's kind of weird. Because I'm in parametrics, I'll change that to t. I want to find the value at 2, and I just press enter. Now be very careful. Don't plug in the derivative. You want to find the derivative of the original function. So I'm going to type in sine of t cubed, t to the third. And I press enter, and I get this negative 1.746. Now if I were real lazy, I could do this. For derivative at a point, remember, change that to a t again. Now, remember, we typed this into our last equation, into our graph. So what I'm going to do is I'm just going to type this function in. And I can do that by saying x1 of t. Oops, sorry, that's delete. Sorry, I'm still looking for a 2. Sorry, enter. So now when I type this in right here, watch what I'm going to do. I already have this into my graph. And it's in the position x1t. So I'm looking for my x coordinate. So I can go x1. That's going to go to my graph. Look at the equation x1 of a variable, and just type in t. And if I hit enter, I get the same exact answer. I'm going to do this with the y. So now if I want to get my y component for the derivative, same thing. Menu, calculus, derivative at a point, still t, 2, enter. But now it's in the y position, y1, so it's going to go to the y part of my graph of my parametric, and I have to go of t. and press enter, and I get this 3.027, which if you remember from part A, that's what we got. And that's all you really need to do. It's pretty easy to do. So if I want to get the position, same idea. I need, like, if I want to find x1, right, the position at 1, it's going to be the antiderivative of from 1 to 2 of x prime of t dt. Using my FTC, that's going to give me x of 2 minus x of 1. And what I can do now is I can just type this in my calculator. So I do it the same way. Menu, calculus, but this time a numerical integral from 1 to 2. Now earlier we just typed in the equation, but remember I have this typed in. I can just type this in as x1 of t. Now be careful, choose dt. You have to change a variable there. Hit enter, and I get this 0.218. We know that that value is 7 minus x of 1. And I can solve that again. Minus 7, change my sign. x1 equals 6.782, which is what we said it was before. So if I want to find the y1 position, 1 to 2, y prime of t dt equals y of 2 minus y of 1. And I can just type that in my calculator. So I go to menu, calculus, numerical integral from 1 to 2. Pressing. Now again, I can just type in my derivative equation, or I already have it typed in into my graph. I can just type this as y1 of t, and don't forget dt. Press enter, and I get this negative 0.443, which is y2, we already know it's 4, minus y1, and solving it, this one's pretty easy. Subtract it, we get, and change the sign, I get positive 4.443. So we get our new vector, 6.782, 4.443, and it's the exact same as we got in part 1. So I hope you guys enjoyed the little calculator exercise here, and I hope to see you guys soon. Bye-bye.